You know that moment where you put something down? I just lost my glasses. And you're sure you put it down, but the next moment it's gone, or you find it somewhere completely different. I mean, people come up with some pretty crazy ideas of what could be the reason for that. Obviously not their forgetfulness. Me as a physicist, I like to blame quantum tunneling. Quantum tunneling, you ask? Well, let me tell you about it. So we live in what physicists like to call the classical world. That means the laws of physics that we learn in school, usually, gravity, friction, opposite and equal forces. These govern most of what we see and do in daily life. According to classical physics, it is impossible for an object like my glasses to pass through a barrier, such as a table or a wall. But quantum physics has a slightly different answer. In the quantum world, objects or particles such as atoms, which in the classical world we give size and mass and velocity, well, they aren't so well defined. In fact, it turns out that we can describe these particles also as waves. And so most of us know waves and water goes up and down. But these are probability waves. That means you have certain points in space where you have a high probability of finding that particle, and other points in space where that probability is more or less zero. And so what happens when that probability wave hits a barrier? Well, if that barrier is small enough, you have some probability of finding the particle on the other side. And this might sound like magic, but it has real-life consequences. In fact, it's the only way we can explain why the sun burns. So in the sun, two hydrogen atoms have to come together to form helium, give up energy, light, heat, keeps us warm. But classical physics tells us that these two hydrogen atoms don't have enough energy to overcome the repulsive force pushing them apart. So this is where quantum tunneling comes in. It turns out that the hydrogen atom actually tunnels through the barrier, which in this case is the force pushing the atoms apart, in order to fuse to helium. The probability of this happening is still super, super small, but because there are so many atoms in the sun, this still happens on a regular basis, keeps the sun burning and us warm. For everyday objects like my glasses though, well, this probability is so small that even if we waited the lifetime of the universe and longer, with almost 100% certainty, we wouldn't see this happen. So, blaming my forgetfulness on quantum tunneling, maybe not the best